So I've been working as part of the research method support team, providing support to CCRP grantees for a number of years now. And we come across a lot of common statistics and research methods in helping to address requests that come from grantees. Some of the time, though, we come across some things which are not so standard. And I think in this particular presentation, I'm going to summarize a little bit about the direct support that we do in terms of providing statistical support to the CCRP program, and mention some of these very common statistical methods, and point you in the direction of some of the resources that we've been making available on the basis of the common kind of request problems that we see people come to us with. And then also mention a few of the more interesting, less standard problems that come up. And I think that's one of the areas in which the RMS team is able to do some quite interesting work, because we are a team and we all come with different expertise and experience of different research designs and statistical methods and non-statistical methods, if we're thinking of qualitative research as well. But all of us have experience now working in an agroecological context and thinking about what methods are maybe going to be a good fit for people working in this area, and different research questions which are coming up through this area. And the kind of support that we can provide covers all sorts of things, from something as simple as calculating a mean or reorganizing an Excel file to some quite niche statistical techniques. But what we will always try and do is try to understand the problem as best as we possibly can, so that we can guide our support in the right direction. Maybe it's going to be guided towards some very standard tools and some standard methods. Maybe it's not. But I think it's important to try to do the best job of understanding the question as early as possible, so that things can be designed in the right way if we're still able to provide input to the design, and so that we're not wasting time going down very complicated statistical rabbit holes if something more straightforward is going to be enough to address particular questions, or if it's something different that is going to be needed to address particular questions. Once we have a data set to work with, then our first step is always to try to understand the quality of the data. And maybe there's going to be some cleaning or data manipulation or data management needed. And this is one of the areas over the past few years we've been really putting an emphasis on providing resources for. I've provided here the link to the YouTube channel. There's lots of videos on data management and a full training course on data management, which we've made available over the past couple of years. Because if we don't have good quality data, we're not going to be able to do any statistical analysis or any meaningful statistical analysis on that data, where there is still tidying or questions about the quality. And before we get into any statistics, be it standard or non-standard, something that we always want to look at is some exploratory data analysis. We want to do summary statistics, we want to do plots, we want to try to understand what the data is telling us, what the story of the data is, because this is going to help inform some of the decisions in the analysis, and sometimes an exploration of the data, if it's done well, is going to provide us much more information and be much more useful than worrying about p-values and confidence intervals and so on, if we can understand very clearly and in very real terms what the trends and patterns are in the data. It also lets us identify, again, if we've made any stupid errors in our data collection process. For example, here was a project I worked on this year where there was a plant which was 2 meters high, where all the other plants were around 20 centimeters high. And I think this was very clearly a data entry error. If we hadn't spotted that, that would have had big implications when we come to the analysis, because one single observation is going to really drive up the mean value and really do odd things to the statistical analysis. And if we don't spend time exploring and understanding the data, issues like this maybe aren't going to arise. And with this particular case that we worked on, this was something which lent itself to a more standard statistical methodology, because we had a randomized complete block design, a very classic design that goes back almost 100 years, thinking of the work done by Fisher in the design of experiments, bringing together replication and randomization and blocking. So this is another area where we've been providing resources on how to deal with these standard agricultural designs, one of which was done here, and we were able to perhaps get a better understanding of the performance and variability across the traits of the Bambara in this particular instance. But in many cases that we work with RMS, we'll see that what's needed is maybe not something that fits so nicely into a randomized complete block design. If we're thinking of an agroecological context, we're more usually thinking of something in a real world conditions rather than in these nice, tightly controlled research stations. A lot of the methods, though, and the statistics are very common and share a lot of common DNA, at least, with the classical work done by Fisher 100 years ago on how to do an analysis of variance. And understanding these more straightforward, more standard designs really helps the analysis when it comes to a more complicated design. If you're thinking of assessing yield on hundreds of different farmers rather than the yield from hundreds of different plots, we've got a few more things to take into account because the farmers are not all tightly controlled in a research station. There's other real world conditions to account for. But if we're trying to assess how the yield varies for different varieties of Bambara planted by the different farmers, a lot of the methods are actually going to be quite similar to doing a randomized complete block design, even if a lot of more classic statisticians may tell you the exact opposite and that they're completely different things. Sometimes working with CCRP, though, we'll find completely different kinds of examples. So I've included a few very non-standard examples, but this is not a full picture. I'm just thinking of what I can cover in a short presentation. On the left is an example where we were trying to understand the relationship between themes being mentioned in some qualitative interviews with experts who were asked to try to characterize what would happen under different kinds of landscape transformation. We were looking for common themes and linking them to common sorts of transformation and seeing what kind of clusters we could build from the data. And this required a sort of categorical cluster analysis known as a latent block model to try to understand. This is not something that I have a link to a resource for because it's a more niche statistical method, which was relevant only really for that particular data set. There may be other cases where we'd need to come across it as well, but it's not something that you would perhaps learn by standard unless it was something that was needed. And we were able to support and provide input towards the publication here that the team were working on. We've also looked at simulation modeling of soil carbon levels and what would happen for hundreds of years into the future, something that you could never possibly do a field trial on for that length of time, and trying to understand how different inputs and different land management practices would change the soil carbon under different kinds of environment. And there's all sorts of other interesting statistical methods that may come across on the way that would not be covered in your standard agricultural analyses, whether this is to do with making predictions from soil data in terms of trying to calibrate what different parameters may be in the soil, all of your different chemical parameters and so on, working with genetic analysis, working with more complicated trials over numbers of seasons with different farmers, all growing different varieties. All of this is the sort of thing that we love providing support with and love trying to work on what is the best possible way of analyzing the data and summarizing the results to provide useful and actionable conclusions. And we hope over the past few years we have been doing this as best as we possibly can, as and when we get support for a request from CCRP grantees. This is something we're also hoping to continue doing going forward. And the answer to how I can get support is simply to ask us. We can't provide this kind of support unless we know what support is needed. So it doesn't matter if you get in touch with Rick or Carlos or a member of the regional team. Hopefully they will direct it towards us as the research method support team. And as you can see, we've got a number of different people, both in terms of Stats for SD and also the team at IDEMS. And all of us have slightly different expertise, slightly different specialities, which we hope lets us give you the best possible support that we can to whatever your request for research methods will be. And we can continue providing these nice results from your research, which can lead to publications and lead to really useful findings coming from the CCRP program.